Welcome to the Hotspot. I'm your host, Arman Dezfuli-Arjomandi. Today's episode is part of our series about Helium's 2021 roadmap with Helium CEO Amir Haleem. Amir joins us to discuss why proof of coverage security is such a difficult issue to solve, and why 5G might be coming to the Helium network in a much bigger way and much sooner than any of us might have imagined. Let's move on to proof of coverage.
Yeah.
It's been a absolute driving force in the growth of Helium, has created an incredible feedback loop of just reinvestment in the hotspots. And proof of coverage, though, has been hard to protect. There have been exploit situations, especially early on, and it seems like the team has been working tremendously. It's like a cat and mouse game, right? It's not something that can ever be fully solved. I'd love for you to just speak a little bit about the team's progress since the very beginning. If I recall, in the beginning, there were almost no checks on proof of coverage, and now it's pretty damn hard to do anything to exploit the proof of coverage algorithm.
Yeah, we had a lot of ideas for how this would work. I mean, it's a very, very difficult problem to solve in the way that we wanted to solve it. Like we wanted any time, like most blockchains don't have this problem, right? Like most blockchains live entirely online and they don't have, the Oracle problem or the meat space problem or like whatever you want to call it, where somehow you have to get something from outside the blockchain and prove that it is true. There are ways to do it that I think were different or better than the way that we did it, but they had trade-offs, right? And in hindsight, maybe those trade-offs were worth making. For example, like we could have encrypted the communication between the radios and the CPU, right? Like, so one of the biggest problems today is that it is possible to fake all of the data that comes off these devices because it comes off the device as a JSON object, right? And you could change any of the fields in the JSON object. You could change the GPS coordinates. You could change the RSSIs, the SNRs. A way to protect against that could have been to encrypt between the radio and the CPU, and require those keys to be on chain. Then it would be almost impossible to spoof the value. Like it would not have really have practically been possible. The reason we didn't want to do that, it did occur to us, was that we wanted to try and have some chance of being compatible with the existing ecosystem of gateways, right? Like to me, that was one of the most interesting things, was that there's sort of an uncapitalized or untapped universe of LoRa gateways that could be converted. So we made that trade-off knowing that that was potentially a problem, right? Was that if we didn't do this and we left it sort of unencrypted, like in the clear like this, that it could happen. We had various other ideas. We still do have many ideas for like how we can improve the state of affairs, but that was one of the reasons we didn't go that way. And I think that probably in hindsight would have been the right way to go, because we kind of ended up there with HIP-19 anyway, right? Where we've sort of said like, okay, you do have to register a key of some kind. And, so we sort of ended up in the place that we didn't really want to end up in. So in hindsight, I would have done it that way, right? Like we should have encrypted the communication between the chip and the CPU, and it would have made it a lot harder. On the other hand, the fact that we didn't has allowed vendors to like more easily join the ecosystem, right? Like a vendor like Broan or Curlink doesn't have to re-architect anything they did, right? Like they have existing products. In Curlink's case, it already has a key store, built into the hardware. So some part of what we said came true, right? Where it is now easier for the existing like LoRa ecosystem to join Helium than it would have been if we mandated encryption between the radios and the CPU, because no one is doing that. Like I've not heard of anyone doing that. Yeah, so that's been it's just been a constant battle. I think we've done a lot of really good work. Like some of the HIPs have helped. 15, 16, 17 all really helped in this problem. There's a lot of work that we've done that we haven't really explained to anyone. Nearly all of it is open source, but not all of it is. But even if it's open source, we have no explanation for what it is or what it does and why. And I don't think we've done anything nefarious there. It's just, and we will open source it and explain it as part of validators. It's purely just misdirection at this point, right? Like if you know exactly how it works, it's much easier to circumvent it. And really the ultimate solution is just going to be density, right? Like it gets harder and harder to cheat when there are more and more hotspots that don't belong to the cheater, right? And so, and there's lots of different ways that we have begun experimenting with to sort of force that to be true. And there've been various ideas, like economically, that have been proposed. Like, well, what if those island hotspots, where there's like 20 of them in a city, like what if they don't earn anything, or if they earn substantially less until they become part of a bigger network? And so all sorts of ideas that I think can work. They all require a lot of like research. And this is one of the decisions that we made early on, was that we could either spend the next 2 years researching the best way to do this, or we could just launch with a thing that we knew was imperfect and work as quickly as we could and engage the community to help us as quickly as we could to like improve it. And that's the direction that I hope it goes in, is that I know Dewey already has a research grant of some kind for PoC. Now I would love for the community and the sort of like crypto community at large, more on the cryptography side rather than the cryptocurrency side, to sort of get involved in this, because it's a really interesting problem that has so many different ways to solve. And I think we're all sort of trapped in the box a little bit now because we know exactly how the current system works. Like it's difficult to think outside of that box a little bit. And all sorts of other ideas have been proposed, like, maybe there's a secure GPS tracker that works. And then it's like, well, what about replaying the same packet? And, all sorts of problems to the solution immediately get presented. But I'm still optimistic there. And there's a lot of work that we're doing that we think is meaningful. But it is fundamentally a very, very difficult problem to solve. In the end state of the network, when the network is large and you have things like LTE and 5G, like the predominant reward should be going to like usage. And that's really going to be the fix, right? Is that people are going to be more incentivized to like maximize for usage, like putting LTE and 5G hotspots across the street from Starbucks. That's going to be the way that you sort of drive towards that in the end states. But for now, I think the work that everyone has done has been very effective. I think gaming is fairly minimal. It's not gone, but it's minimal at this point. And the rewards are not meaningful compared to what they used to be. So overall, I'm sort of happy with the progress. I'll never be satisfied with it because it never quite did what I wanted it to do or what we all wanted it to do at the start. But as you said, it's been a phenomenal catalyst. And for the most part, I think really does a good job of proving coverage. But yeah, a lot of work to do there. And that is like sort of an infinitely unsolvable problem, and there's just so many different ways to improve it.
So you mentioned CBRS and 5G. I'd love to talk about what the progress has been on that side. I mean, for me, I focus a lot on LoRaWAN. I think there's so much to be done on the LoRaWAN side. Clearly, there's validators, light hotspots, and just the network is still young. It only has 20,000 hotspots, 180,000 on order. I've seen some interesting developments around CBRS and 5G. As you mentioned, the FreedomFi announcement was very cool. They've been doing some great presentations on the community calls, and it seems like they're moving really, really fast. Very eager to interview Boris from FreedomFi. But I saw that you posted some photos of a phone getting 110 megabits per second. It said LTE in the top left, and it was some cryptic code instead of the carrier name. So can you explain what's going on there? Is that your phone? Is that your setup?
Yeah, that is. Yeah, so the FreedomFi guys have been awesome to work with and have sort of, I think, illustrated a much better version of the way that we wanted to do cellular. Like we always intended to do something in cellular. Like that was always a dream. The naive way of thinking of how to do something in cellular is like, let's beat AT&T, let's create a carrier. And like you can't reasonably do that for like a bunch of different reasons. I mean, I wish you could. You just, in the States at least, you just can't, right? And the FreedomFi approach has been much smarter than that, which is basically to say, like, look, if you had a big network of cellular capable hotspots, what you can do is engage with existing carriers and convince them to roam onto that network whenever it's available, right? So, for example, like if there's bad AT&T coverage inside of Starbucks, or it's expensive for AT&T inside of Starbucks because they have to like buy bandwidth from someone, then if a Helium hotspot was available, maybe they would roam onto that because it's 1,000 times cheaper and coverage that is both cheaper and in more unusual places than their existing network. A lot of the carriers don't own their existing networks. Like they have to pay tower companies, for example, per gigabyte for data that flows through that. So even though they may have coverage in an area, they may prefer not to use it if there was an alternative because the alternative might be a lot cheaper. So this is a very smart approach from the FreedomFi team in their way of thinking, right? Is that they sort of saw this as a way to sort of break into the market. And I think their long-term vision is very different from what our long-term vision is, or the long-term vision of the network, but they're still very symbiotic and closely aligned. The main thing that unlocks this is a project called Magma, which is an open source cellular stack, effectively, that Facebook started to develop and has now sort of rolled out of Facebook as its own thing with its own Linux Foundation membership. And that's sort of the key unlocker, right? Is that like cellular protocols are, unlike LoRaWAN, unbelievably complicated to implement. I mean, absurdly complicated. Never seen anything like it. So the ability for a team like us to implement cellular as a solution, if we had to build the protocol support, is minimal, right? Like it would take years probably for us to figure out how to do all of this. So Magma comes along and sort of has all of the pieces that you need in order to do this, right? They have what they call the access gateway, which is sort of the equivalent to the hotspot. What that enables you to do is take off-the-shelf cellular radios, right? You may have heard the term, the acronym RAN, which is Radio Access Network. And that refers to, the off-the-shelf radios that you can buy that do all of the cellular work. These are like what are on-cell towers, for example. And there's differing versions of these, right? There are like massive ones that cost thousands of dollars, and there are like internal ones that look more like Wi-Fi routers that cost hundreds of dollars, and there's stuff in between. And so the Magma Access Gateway basically allows you to have a box, just like a hotspot, that you plug one of these RANs into. That's an interesting development, right? Because now all of a sudden you can buy an off-the-shelf radio and connect it to a hotspot and become a cell tower, right? Then there's another side of there's a cloud piece called the orchestrator. And then there's another piece called the Federation Gateway, which is like how your orchestrator, like your instantiation, talks to other networks. And so Magma sort of unlocks this and makes it all possible. And a way of thinking about the way cellular could exist in the Helium world is that it sort of has two components, right? One is this symbiotic with existing networks version, right, where you do a deal with AT&T and T-Mobile and Dish and whoever else, and they agree to like roam onto your network whenever it's available, right? That's one instantiation, and I think that would be very, very powerful because there's a massive installed customer base. There's a ton of usage. There are millions of handsets. So you would see usage immediately, like if you were in an area that had a lot of that traffic and you had those deals done. And you can imagine like setting up across the street from a Starbucks with a directional antenna like pointed in the window as a totally viable thing to do, like if those deals existed. And then the other version is a little bit more like the current Helium network, where you could imagine entrepreneurs, particularly outside of the States, but perhaps even within the States regionally, becoming network operators, right, where they own the subscriber, and it's like a private network sort of for that operator, and not private, but the traffic is sort of owned by whoever the user, I should say, is owned by the operator there. And I think that's amazing if you think about developing world and areas where there's no wireless infrastructure today. So those are like the two ways that I think cellular can exist. There's a lot of work to do in the States because it's such a complicated business development process. Like you got to go to AT&T or whoever and like convince them that this makes sense. And then you're sort of back to where we are with the IoT thing, where it's like no one believes this is real. Could it work? Like, does it work? Like what about SLAs? Like what's the quality of the call like? And so what we've been testing is how well does that work, right? Like if we were able to build a solution like that, perhaps it's even possible to software upgrade existing hotspots to work this way. What is it? How does it work? Like what's the range like? Like what's the speed like? And it's been surprisingly good. I mean, the range is nothing like LoRaWAN, right? Like this CBRS runs in 3.5 gigahertz. 3.5 gigahertz does not like going through anything. It doesn't like trees, buildings, doesn't reflect off much. So the range is nowhere near, is nothing like LoRaWAN. Like if you got a city block, you'd be in good shape. And so it's going to be much more about targeted coverage in important places or places where there is a lack of coverage or where there's a lot of people. But in general, it works very well. Like I have a phone that functions, like I'm on LTE and I'm getting 110 megabit per second down the street from my house. And that alone is kind of amazing because I didn't think it would be possible to do that. And, I think there is probably a path where you could upgrade the existing hotspot fleet to be cellular capable. You'd still have to like add the cellular radio. You'd still have to go buy that thing, which is anywhere from $500 up. But it's an interesting idea, right? All of a sudden, your entire deployed network can upgrade itself to also serve cellular is really neat and interesting. So, but that's sort of the path that we're going down now with the FreedomFi team is like, okay, like how would you roll this out? Like how do we get a pilot going with one of these carriers? Like how do we get someone to bite, basically? Like you need one pilot in one city to prove that this actually works, and then I think it blows up. And so there's a lot of discussion in the channel about like who, what's the pilot city going to be, and like almost like pitching like the Olympics or something. Like we think it should be in Cleveland. And I think it really depends on the carriers to some extent, right? Because without the carriers, at least in the States, like you don't have users, you don't have customers, right? Because there's no way to really, you could try and become a telco and own the customer, but I think that's a incredibly complicated task. And so it's better served to try and roam with existing carriers, and so you have to sort of work with them at this stage. And we're having a lot of conversations with those guys, and we'll see how it goes. But I think it's a fascinating development, and if we did it, I think there's a chance that Helium becomes the largest. They call these things neutral host networks, where where you've got a cellular base station, but it isn't attached to specifically one carrier. It can serve several of them. I think there's a chance that Helium becomes the largest neutral host network in the country over the next 24 months if done correctly.
What is the sell, no pun intended, to the carriers? Are they looking at cheaper data rates or more as you said specific coverage like inside buildings that they just couldn't feasibly build out before?
Yeah, I think it's both of those. I mean, I think getting indoor coverage has always been a challenge for cell companies, right? Like, for example, in an airport, right? Like they have to pay for that, right? So someone runs that network. Usually it's Boingo or someone like that, right? And a cell company have to pay Boingo per gigabyte for being on that cell network, right? So when you see LTE or 5GE or whatever on your phone, like you're going through someone else's towers to get back to your network, and that's expensive. And then there's also like soft spots, as they call them, right? Where areas where they don't have great coverage. Like there's something there, but it's not very good, right? And the current model of deployment is quite expensive in terms of adding towers. So they don't have a lot of like cost-effective ways to like solve for soft spots today, right? And so yeah, and we're learning a little bit also, right? Like we're having conversations with these guys to understand what their pain points actually are. Like, do you even have any pain points, or like is this a problem that is interesting or not for you? And the answer seems to be like it is a problem that's interesting for them. Like they don't have a way to grow their network that is cost effective. The populations themselves grow and move away from where coverage areas used to be, right? And so they have to constantly keep adding towers or paying other vendors for access to towers that they've built, whether it's Crown Castle or American Tower or Boingo, or like there's a whole ecosystem that lives there that does this. So we're learning a little bit also, like trying to understand the business of cellular and telecom. But what we are finding is that there's something interesting here. And based on the success that we've seen with the IoT network, we have no doubt that it could be replicated, and a very large neutral host network could be built this way. And the question is like, how does it work after that? And we have all sorts of phenomenal ideas for like what the on-chain instantiation of some of those ideas are. But first, I think, the older, wiser version of us wants to understand, like, does the customer actually find this to be interesting? Like, is there a problem here that they would pay money for? Because ultimately that's the money that goes to the hotspot hosts. Like if you set up across the street from Starbucks and there's a business development deal done with AT&T, you're probably going to earn a bunch of HNT for serving traffic out of the Starbucks. And that's what we're trying to get to.
I love the diversity that this brings to the Helium network. You have two very diametrically opposed networks that you're building at the same time. First, you have the LoRaWAN network, which is globally ramping up, doesn't have the same installed base as cellular, certainly doesn't have much of an install base at all in the US. And then you have the opposite. You have the cellular network where there are tons of existing devices, and literally all you have to do is put something up once the deals are made, right? Put something up, become your neutral host carrier or node operator, whatever it's called, and within 5 minutes, someone is roaming onto your cell. That's kind of a magical thing. So it really diversifies, in my mind, the risk of the network, right? You're taking two very ambitious, practical bets at the same time.
Yeah, and they're different goals, right? I mean, the IoT network makes sense to do the way that we've done it because there are no IoT networks, right? Like, and so the problem to solve there was different, right? It's like, how do you build a ubiquitous IoT network from scratch? The community in general has done a phenomenal job of that, right? Like the network is like, forget PoC and everything else. Just look at the coverage mapping that people do in the different cities. I mean, the network is like legitimately everywhere at this point, and still a long way to go. There's still massive swaths of the United States that are uncovered, but in major cities, it's totally usable, right? And that's incredible. And that the goal of the IoT network was exactly that. The goal of the cellular version of Helium, again, at least in the United States, can't be that, right? Because there are regulatory problems. Like we can't get access to the spectrum that we would want to like broadcast at high powers. And you have to own the customer and the subscriber. And there are just massive amount of regulation and legal around that process, being a common carrier. And like, it's a very, very different world. And the goal of the cellular network, therefore, I think is quite different in Helium. Again, at least in the United States. In other countries, I think you can recreate what we did with the IoT network in those countries. Like if I'm in a rural area and there's no cell network operator and I can somehow get access to the spectrum I need, you could instantiate a whole cell network in that country and own the customer and break new ground. But it's still interesting because it will force the deployment strategies to be different for cellular, right? Like you will want to optimize for areas either where there's maximum usage or the worst coverage, right? Like those are going to be your bets. And I think you're going to see all sorts of interesting strategies, and the cost is not prohibitive. People are buying hotspots on eBay for like $5,000 right now. It's feasible that you can build the cellular hotspot for somewhere between $500 and $1,000. That makes the deployment model for everyone involved very, very different, because I don't think the telcos today have a way to like create new coverage areas that cost less than $1,000, particularly when people are paying them the $1,000 or are buying the hardware for themselves. So it's a very, very interesting model. It could be wildly successful if the execution was even half as good as what's been happening in LoRaWAN. It would be explosive.
Do you think that there's a chance that the cellular network might not need proof of coverage rewards at all and just might skip directly to data credits since there's so much existing usage?
Boris and I were having this conversation the other day, and it's like, the range of the cellular stuff is so much worse than LoRaWAN, that the way proof of coverage works today would just be completely ineffective. Like, you'd have to be a block away. You'd have to have a chain, of hotspots that are like a block away from each other. And I just don't know how useful that is. And so it's feasible that you end up with a situation where every cellular hotspot is also a LoRaWAN hotspot. The incremental cost of supporting LoRaWAN is extremely low, right? Like you throw in the LoRaWAN module, or the LoRa module, which is, I don't know, whatever, at volume, $20-$30, maybe less. So that might be a way to do it, right? Is that, you use PoC for LoRaWAN, and you use data credits for cellular, because the cellular network is much more about providing immediate utility, because that's how, given the range and everything else, like that's just how it's going to work. So possible that it goes that way. I know there's still a lot of discussion to be had there, and this HIP 27, which at least took a shot at trying to do that. But I do think the range is going to be a challenge. Like it's just not the same. Nothing's the same. That's why LoRa is LoRa. It like goes 100 miles or goes everywhere, kind of thing. But you can do it with cellular, but you've got to be up high. You've got to be broadcasting at very high power, which you can't really do in CBRS because it's the unlicensed band. And the equipment to do it is going to be more expensive. Like I've got an antenna here, which someone told me was like $2,000. And so it's, I don't know if you want to buy a $2,000 antenna, right? It's just different. Everything's different in the cellular space.
Thank you so much for tuning into The Hotspot. If you love our content and want to support us even more, please consider subscribing on Apple Podcasts and leaving your honest review. This will help the podcast reach more people and educate them about the Helium Network.